Welcome to Akshara Foundation's video on place value. To help you teach this important concept, Akshara Foundation's Math Kit has base 10 blocks, place value mat, place value strips, abacus, and play money. When children have learned counting, they will know the mapping of numbers to the quantity. For example, 7 of any item refers to the quantity 7. Similarly, as they proceed to counting bigger numbers, they need to understand how to represent bigger quantities with the same digits from 0 to 9. The number system with base 10 blocks enables us to do this by assigning places to the digits. For example, how is 74 different from 47, even though the digits are the same? Show students the base 10 blocks and introduce them to the rule of grouping by 10. Yellow cubes represent ones or units, blue rods represent tens, green plates represent hundreds, and the red cube represents 1,000. Ask them to count and set aside 17 yellow cubes. Place 10 of these yellow cubes below a blue rod. Observe that they are equal. So we can now replace 10 cubes with one rod of 10. 17 can thus be depicted as 1 10 and 7 ones. We have regrouped by tens and the value of the number has not changed. Show the place value mat and place the tens rod in the tens column and the 7 cubes in the ones column. Write some numbers on the board and give cubes and rods to students. Ask them to group by tens and place cubes in the ones place and rods in the tens place on the place value mat. 23, for example, is 2 tens and 3 ones, and so on. Remind them that the column on the extreme right is the place for ones. Here, a maximum of 9 ones can be placed. The column to its left is the place for tens. Here, a maximum of 9 tens can be placed. Ask students to add 56 and 78 on the place value mat. 6 ones plus 8 ones gives 1 10 and 4 ones. When 5 tens, 7 tens, and 1 10 are added, we get 13 tens. So now we replace 10 blue rods with 1 green plate of 100 and move 1 place to the left. 56 plus 78 is 1 green plate of 100, 3 blue rods of tens, and 4 yellow cubes of ones. Show how to represent numbers which have a 0 using base 10 blocks. For example, 401 has a 0 in the tens place. Let students now try more examples for practice. Now, let's look at 4-digit numbers. The red cube in the math kit represents 1,000. The thousands place is one place to the left of the hundreds place. Show how to represent a 4-digit number using base 10 blocks. 1,426, for example, is 1 red cube, 4 green plates, 2 blue rods, and 6 yellow cubes. To reinforce this concept, give a handful of cubes, rods, plates, and a big cube. Now, ask students to place them on the place value mat and write down the number it represents. If we have to pay a shopkeeper 1,415 rupees for buying some clothes, it is not convenient to carry the entire amount in 1 rupee notes. Grouping by tens makes this easier. 10 1 rupee notes are equal to 1 10 rupee note, 10 10 rupee notes are equal to 1 100 rupee note, and 10 100 rupee notes are equal to 1,000 rupee note. It is now convenient to give the shopkeeper 1,000 rupee note, 400 rupee notes, 1 10 rupee note, and 5 1 rupee notes. students learn very fast with play money. Give few 1 rupee notes, 10 rupee notes, 100 rupee notes and 1000 rupee notes. Write different amounts on the blackboard. They must call out each amount correctly and then place the money in the appropriate column on the place value mat. Introduce the abacus from the maths kit, which is useful for 5-digit numbers. Yellow rings represent ones, blue rings represent tens, green rings represent hundreds, red rings represent thousands, and white rings represent 10,000s. Show students how each rod can hold only 9 rings. Hence, if a student places 7 yellow rings of ones on the rod and adds 6 ones, she will have to place the add-on rod to hold rings beyond 9. 10 yellow rings have to be replaced by a blue ring. So we now have 1 10 in the tens place and 3 ones in the ones place, representing 13. This process is repeated for digits in every place. 10 tens or 10 blue rings are replaced by 1 ring representing 100. 10 hundreds or 10 green rings must be replaced by 1 red ring representing 1000. 10 thousands or 10 red rings must be replaced by 1 white ring representing 10,000. Place relevant colored rings on the abacus and let students say aloud the number it represents. For example, 12,345. After students have understood the concept using different teaching aids, it is now time to practice on the grid. The different columns on the grid show how many ones, tens, hundreds, thousands, and 10,000s are there in any number. Now, students will be ready to learn about the difference between place value and face value. Ask students to depict 1,252 with base 10 blocks or with play money. As the name suggests, the face value of a digit is the digit itself. To find the face value of 2, count the number of cubes or 1 rupee notes. The answer is 2, so the face value is 2. The place value of a digit is the value it acquires because of the place it occupies in the number. To calculate the place value, we multiply the digit by the value of the place it occupies. Since 2 is in the ones place, the place value is 2 multiplied by 1, which is 2. There are 5 rods or 5 notes in the tens place, so the face value of 5 is 5, and the place value of 5 is 5 multiplied by 10, which is 50. There are 2 plates or notes of 100, so the face value of this digit is also 2, but it is in the hundreds place. So its place value is 2 multiplied by 100, which is 200. In other words, the 2 in the units place has a different place value from the 2 in the hundreds place, though the face value is the same. Finally, in the thousands place, the face value of 1 is 1 and its place value is 1000. To explain the role of a zero, take a number such as 570. The face value of 0 is 0. What is the place value of this 0? It is 0 multiplied by 1, since 0 is in the units place, and hence the answer is 0. But if the 0 was to be dropped from 570, the number would change to 57, which has 5 tens and 7 units and no hundreds at all. Thus, students must remember that the 0 has an important role as a placeholder. For practice, let students represent a few more numbers on the abacus or base 10 blocks and then write the face value and place value of each digit. Now that students have understood the place value of digits, they need to know how to write the expanded form of numbers using place value strips. First step, represent the number 3745 using paste and blocks or play money on the place value mat. Introduce students to the place value strips. Red strips represent thousands, green strips represent hundreds, blue strips represent tens, and yellow strips represent units. Second step, arrange the place value strips. Start from the highest place value or the digit to the extreme left. 3 is in the thousands place. The place value of 3, as we just found out, is 3000. The red place value strip marked 3000 represents the digit 3. The digit 7 is in the hundreds place and is equal to 700, represented by the green strip marked 700. Place this below the red strip. The digit 4 is in the tens place and is equal to 40, represented by the blue strip marked 40. Place this below the green strip. Finally, 5 is represented by the yellow strip marked 5, and 5 into 1 is equal to 5. Place this strip below the blue strip. It is important to align the strips to the right. This shows the expanded form of 3745 as 3000 plus 700 plus 40 plus 5. Third step, rearrange the strips. Place green over red, next blue over green, and finally yellow over blue, all aligned to the right. We can now see the contracted form of the number. Till they master the concept, let students follow these steps and practice first with blocks or play money or abacus. Then represent the numbers with place value strips. Show students how to write the expanded form of numbers in a grid taking the same example. They can now learn to compare two numbers. Which is greater of the two? 2365 or 2356? Let students mark the number of ones, tens, hundreds, thousands on the grid. Remind students to start comparison from the highest place value. Compare and strike the number of thousands in both numbers. They are both equal in number, which is actually the face value of the digit. Now compare and strike the hundreds in both numbers. These are equal as well. Now compare and strike the tens in both numbers. 2365 has one 10 more than 2356. Now there is no need for further comparison. 2365 is greater than 2356. For practice, students can start by representing numbers using the teaching aids in the math kit and then move to working in a notebook. Students pick up fast through peer learning when they work in groups, and then they will be confident of answering any problems.